Okay, this is take 2. Hopefully we don't crash again. Yeah. I added a delay at the end. Yeah, this it doesn't crash again. Seems to be working. Try it. Yeah. Okay. It's fine. We're good. Yeah, so I guess I could just proceed. Unless there's something else. No, not yet. I would like to look up the STL API a bit more. Cause I didn't write this. This is from an example. So yeah. I'm not sure how it works yet. Alright, let me go. Is it gonna be loud?
Record button. And off we go. Okay, hello everyone, and welcome to day 2 of the Handmade Hero coding sessions. Yesterday, last night, we learned how to basically set up a dev environment. So not terribly exciting stuff, but stuff that has to actually happen. And basically what we did is we configured this command prompt, and we got it to the point where we could launch our own editor, which in this case I am using Emacs. But you can use whatever you want to, although the Emacs file is included in the source distribution if you would like to try it. We started by making a little simple Win32 application here that just starts up and launches a message box. We made the make file for it, quote unquote.
I have to say the Windows stuff in Windows looks a lot better. Just saying. Doesn't look great, but it looks better than
Quote, which is basically just a batch file that I wrote, which compiles something directly into a build directory where we can run it. And we learned how to launch the debugger, which is Visual Studio Community 2013, if you have not already downloaded it. And we can do stuff like step into our code and watch it run. This is Handmade Hero. But a message box is not a particularly useful thing for a game to pop up. In fact, if you have seen one pop up in a game, it usually means that the game has encountered a very serious error of some kind. So what we are going to do tonight is try to open a window that is a little more useful. And what that kind of window is we're going to open basically just a standard Windows window, because pretty much any window that you're going to open in Windows goes through the same sort of path for opening it. But then what we are going to do is we're going to create a special, essentially, buffer in memory that we can write into ourselves and do all of our rendering into ourselves, and then we are going to show how to display that buffer in the window. Now, this is not exactly how a modern game would usually start up, because modern games oftentimes, or pretty much at this point exclusively, let the graphics card do all the rendering for them. And while that is an interesting thing to do, and something that we will probably explore at the end of the series when we are strictly looking at performance optimizations and we want to do things like play around with all that extra power that the GPU gives us, it is not particularly good for educational purposes, because the GPU is basically an opaque resource where we have very limited insight into what it is actually doing to render the graphics for our game. In fact, a lot of the stuff is just flat out trade secrets that we can't even know. NVIDIA won't tell us, or AMD won't tell us how the card is even actually working unless we work there. And so that is the opposite of good for education. May be good for competition in the industry, but not so good for education. So what we are going to do is we're going to write the entire renderer ourselves. And in order to do that, we need a way to display something that we have created rather than something that is created on the graphics card. Okay, so we'll get to that part a little bit later.
Hang on, did he say we're gonna create the renderer ourselves? That means all I need is the window. Interesting. Sounds like a lot of work.
But for now, the majority of our work is just going to be, how do we open a Windows window at all? And even dating back to the very, very early days of Windows, the way that you have to start out to open a Windows is there's a thing called a Wind class. And if you remember from last time I said, you have to get very comfortable with using MS.
Hang on, maybe I should move myself. Yeah. There. Lock it.
MSDN, we are going to search for Wind class, and you will see that MSDN comes up as the first hit, and it has the definition of a Wind class. And you know what? I still don't want to help MSDN improve right now. I'm on a live stream. I cannot take the time to do that. I'm sorry. So, looking inside the MSDN for Wind class, you can see that it is a struct, a good old C structure, but it's got a little extra decoration on it. And I'm going to take a quick second to explain what that is, since we will see it in all of the structs that we look up in MSDN. So I'm going to cut and paste it into here. And you can see that instead of just a struct, like this is the declaration of the struct right here. If I actually cut it out, there is the struct, right? That's the actual structure. And if you remember from the intro stream, or if you're familiar with other computer programming languages, a struct is basically just a record. It's a collection of variables that go together. And when you refer to one, you're referring to basically a memory layout where each of these individual things is sequentially ordered and usually stored back to back. But as we saw on the intro stream, depending on the sizes of the things that are in that struct, they may actually have padding in between them to maintain what's called alignment. And we will be getting to alignment actually, potentially even later in this stream, but certainly tomorrow if not. So I'm not going to talk too much about alignment right now. But point being, this is the Wind class struct, and you will notice that instead of being called Wind class, which would look like this, it is actually called tag Wind class. And you might wonder why that is. Well, the reason is because the Windows headers are trying to support basically, I want to say that they're trying to support older versions of compilers, I guess, because I don't think any current versions of compilers have this problem, but it may also be because they've got some kind of system that they're trying to maintain or something like this. But basically what they want to do is they want to support both C and C++ compilation. Now what happens in C++ is that if you declare something struct foo, you can then immediately start using foo to refer to things of that structure. So if I do this and then I say that I have one of these foos, I basically use the word foo as if it's just unannounced. It's just a foo. You know what it is. It's one of these structs, right? Totally clear, no ambiguity about that. But in C, that was not true. In original C, you could not use foo as a word because it did not actually look up the names of types when you did not decorate them. What you had to do is you had to type struct foo, right? So that is how you would have declared a individual one of these foos. It's hard to say. That's how you declare an individual foo, is you would have to preface it with struct. Now when C++ came along, they got rid of that. But if you are still compiling with C mode or something like that, they wanted to support that with the Windows header. So what they use is they use a thing called a type def. Now a type def is just a way of specifying a new name for some existing type that can be specified. So for example, if I wanted to make this work, which I had before, I wanted to make it so that I could type foo foo in C, well, what I can do is I can say type def foo to foo. And basically what it does is you're basically doing what is essentially a variable declaration. It looks basically the same as a variable declaration, and you could even decorate it like a variable declaration with array bounds or a pointer or anything. But basically what it'll do is it'll take the name, and that name will now refer to a type that is whatever the type def was, whatever the type def says it was. So if it's a foo star, then capital foo, oh, you know what? That is actually what I meant to type, sorry. If it is a struct foo pointer, then lowercase foo will now refer to a pointer to foo, and perhaps we should even call that a p foo or something so you can tell it's a pointer to foo. If I just say struct foo foo, then this basically emulates what C++ is doing. C++ is automatically doing this so that we never actually have to type struct foo. We just type lowercase foo, and we get a struct foo in its place, right? So what the Windows headers are doing is they have decided to basically compress all of that into one very concise definition, which is they're saying type def struct tag win class, And then at the end of it, after they declare the structure, the type def, right? This is the type of the type def. They just put the struct definition right in line, which you're allowed to do. The type def then declares two different types, which you can do with the comma. It is basically saying one type is win class, and the other type is a pointer to a win class, and they're going to call that p-win class. So this essentially creates two names, win class, which refers to struct tag win class, and it creates p-win class, which refers to struct tag win class star. Very simple, but that's just to understand what you are seeing. That is what is going on. And that's really all there is to it. Now, it's worth noting that I believe there is no reason you even need to name this struct. You could, if you wanted to, just get rid of the name altogether, and from now on refer to the pointers as this and win class as the actual struct, and you would be fine. So like I said, why they put the tag win class in there, I don't know. It may be some historical reason. It may be to support some kind of compiler thing they need to do. I do not know. I've never looked into it, but this would be the more concise way of doing what they did, which I believe works on all modern compilers now, but you know, maybe in the old days it didn't. Who knows? We will certainly not go spelunking to find out. But the point is, we now have our win class type that we want to define here. And what we are going to do is we are going to define one of these win class structures. And basically what they are is, in the Win32 API, this pattern happens a lot. What they do is they create a struct, and the struct is essentially just the parameters to a function that you're calling. The structure is just a way for you to fill out a set of informational variables that you will then use when you call a function to have that function sort of do things with all of the settings. And I think they did it mostly, I don't know if it was for efficiency or if it was because they just didn't want to make it easier for you to fill things in. But basically what we're going to do is we're going to fill in the members of this with the values that we want for our window. So we are going to define our window class here. And because I'm not going to want to set all of the actual values here, I am going to use a initializer in C, which we did not cover in the intro stream. What that is when you define a variable, and I did show you could do things like this in the intro stream, when you had a simple thing. Like if I had an int, I could initialize this way. But what I did not show is a struct. A struct has lots of values, so you cannot simply say equals 5. It wouldn't mean anything. What you can do, however, is do open and close braces, and then inside there you can actually initialize all of the values. So I could initialize style here, I could initialize LPF winproc here, whatever these values were going to be, right? I could initialize them, and I could initialize as many as I want. And when I stop, all of the values that follow will all be set to 0 automatically. That's just the way that it's defined to work in C. Now, Spec has recently gone and done some crazy stuff with this. It used to be that you could type this, and that was the way that you said, basically, I want to initialize the first thing to 0, and the rest should all be initialized to 0 as well. And I think you still have to do that if you're programming in C. But in C++, and again, I'm not much of a spec person anymore. I think the C++ spec is completely out of control. But I believe nowadays the actual way to say, I'm not going to initialize anything, but I would like you to clear it all to 0 for me, is actually just to put nothing in there. And if you put nothing in there, then it basically takes the entire block of memory that it reserved on the stack for this window class, and it sets it all to 0, which is what I wanted. So we are going to do that. Again, I can show you the compilation here. We can go ahead in and I compiled that right in the editor. I should mention to those of you who are using my.emacs file, Alt-M does the compile. And basically what that does is it will search from the directory that you're in up directories until it finds a build.bat, one of my handy little build.bats. And when it finds the build.bat, it will run it. So that is exactly what we wanted, and it builds our thing for us automatically. So I am going to run in here, and you can see our window class. And if I go in here and I look at the window class in the watch window, we can see that it is garbage. It is just a bunch of stuff. It has not been initialized yet. You can see there's all kinds of stuff in here that we would not certainly want to pass to anything. But when I step over this line, you will notice that it clears absolutely everything to 0, which is what I wanted. So all good. Now, you will see me do this a lot, by the way. If there is not a performance concern in the code that I'm working in, I always use a thing that I call zero is initialization. And we will see this come up a lot, but basically what I like to be able to do is I like to be able to make it so there is essentially no initialization for most of my code. Most of it can just be cleared to zero, and as long as it's cleared to zero, it will work when it goes forwards. I know that sounds a little strange, and it's very different from the C++ model where everything has a constructor and there's a lot of startup-y stuff going on. So I won't really get into how that all works because you'll be seeing how it all works, but I just thought I'd point it out there because we will be using this a lot in a bunch of places. So when there isn't a performance concern where I really got to be specific about how things are getting initialized, oftentimes clear to zero is the way I'll go. So off we go. What are the fields that I want? Well, there are a lot of fields in here, and I am going to initialize only some of them. The style is a set of binary flags, a bit field basically, that are things that we want, properties that we want our window to have. The LPFN wind proc is a pointer to a function, which we'll get to in a second. So we're going to set that, and that is basically a pointer to the function that we will define that defines how our window responds to events. CLS extra is if we want to store extra bytes along with the window class based on our own personal bytes. We do not actually need to do that, so we are not going to use it. CB wind extra, the same thing. It is basically allowing you to create extra memory associated with your window that you can use for whatever you want. H instance, I believe we will have to set because basically it needs to know what instance is setting the window. I don't know if you can short circuit that to zero and not bother setting it, so I'm going to check MSDN. Handle the instance that contains the window procedure for the class. Looks like we probably do. There is no note on that. I don't know, and I don't want to tempt fate, but
I think I can skip through some of this window stuff. It's not really relevant. Going...
what the procedure is right there, which is what I wanted to know. And so what I'm going to do is I'm going to go ahead and cut that out. This is the callback, which is the phrase callback is exactly what it sounds like. It is a thing where Windows calls us back from its code to have us do something for it. And you can see right here what the parameters are to it. It gets passed an hwind, we don't know what that is yet, a unsigned integer. It gets passed a wparam and an lparam, all totally mysterious to us. We have not really dealt with any of these because even the unsigned integer, which we now know is just an unsigned 32-bit integer, we don't know what it means. So what we're going to have to do is look at MSDN and see what that stuff is. But for now, we know that this is our main window callback. This is the callback that will be called anytime we have a window of this class that Windows needs to send something to have it do something. And we'll see a little bit more about that in the future. So what I like to do, and this will probably frustrate a lot of people, so it's just what I like to do. You don't have to do it. I hate all their little prefixes and weird names. As far as I'm concerned, this is instance, this is prev instance, this is command line, and this is show code. So I'm just going to go ahead and just flat out rename those things because I don't like to look at their weird naming convention any more than I absolutely have to. And the same is true up here. I happen to know what these things are, so I'm going to name them what I want to see them called, which is message, window, and then just changing the capitalization scheme there. And what you need to understand here is that function signatures in C and C++ are really only about the types. A function signature, the definition of that function, only depends on the types that you're trying to pass it. The hwin, the uint, the wparam, the lparam, that part. The name of the parameter is up to you. So even though Windows is the person who's calling us, it's only the fact that it receives these four specific things that are important. It does not care what they are called. So you can change them to be called anything that you want, whatever you want them to be called. Literally any name here is fine, so you should name things whatever makes it easiest for you to read. And that is what I like to read, so that is what I have called it. Now, if we go in here, we can see the definition of these things. Basically, we have an hwin, which is a handle to a window. Hwin stands for handle window, basically. And what that is that's just a opaque thing. We cannot really look at it at all, but it is an opaque piece of data that we can pass back to Windows that allows it to know which window we are talking about. So it passes it to us and says, hey, here is the window handle. If you need to talk to me about your window handle, just go ahead and pass this back, and I'll know what you mean. Pretty simple there. The uint, the message. So basically what this is the message that Windows is asking us to handle. It is going to call us back with a variety of different things. And what we need to do is we need to go look at what those things are. So system-defined messages, here is the list. And basically, as you can see, over the ages, it has grown to be absurdly huge, the number of things that you can receive. Now, most of the ones that we care about are not these kind of things. Animation control messages, combo boxes, all this sort of stuff. Since we are not going to be using Windows hardly at all, we are basically just opening a window and then we are doing everything else ourselves, most of the things that we care about are very simple, basic window operations that we need to respond to. So they all fall under the WM category, and we will not really need much from anything else in here. A lot of these things are for if you want to use the Windows standard controls, such as track bars, the task, like these sorts of things where you see like Windows standard controls, buttons that you click on. If you want to use their standard controls, they all have special message codes that they will pass back and forth to you and stuff like that. But we're not going to be doing any of that. If we make a button, we'll be implementing it ourselves, so we don't need to call them. So we are going to be dealing in here, and at first, basically what we need is just our window messages. Excuse me. So I'm going to go ahead and look in here and see if there's anything in particular that we want to handle. I think we basically want just like a few simple things. Yeah. Okay. So the ones that I think we want to handle at start here, and I'm going to use the switch statement that I discussed in the intro stream. The switch statement, of course, allows us to take any value and switch to see basically if it equals any constant that we want to input. So here I am going to use these codes, which are defined in Windows, to be constants. They are specific numbers, basically, that will be used to say which message is coming in. And I am going to field, for example, the WM size command, which is when the user changes the size of the window. I am also going to field probably the WM destroy command, which is when Windows deletes our window. And also perhaps I will field the WM close message, which is basically what happens when the user clicks on that little X up in the corner of the window. And finally, I think I may also do, just at the beginning here, I may do activate app, which is basically a thing that lets us know whether the user has clicked in us and we are the active window or not. And now you'll remember I also said back in the intro stream, if the thing that we are switching on does not fall into one of the constant categories that we have defined using case statements, we can go and actually use a default statement to catch up all of the extra slack. Now, what you are seeing here, probably for the first time, because I have not used this in the intro stream, is the way that I write case statements, which is a little unusual. The way I like to write case statements is I like to actually put a basic block in there. Just define my own block. That is not required. That is the normal way the case statement looks, and this is the code that goes in it right there. But what you will find if you use case statements often is that if you actually define variables in here, those variables will propagate out to the other cases because they are all in the same block, which is this one up here. So if I have an int x, I could refer to it down in here, even though I did not mean for that to happen, which could be a mistake that I would rather prevent. So I always bracket my case statements unless I have a really good
I wonder if that's a C thing. Not sure if it happens in Zig. Interesting.
reason not to do so. And then I go ahead and put the break outside. Most people put the break inside. A lot of times it will look like this. I don't do that. I just think it looks a little nicer if it just looks like a standard basic block and the break goes outside. I also find it helps to keep it from mixing with the other code accidentally, so that's the way I do it. Not really necessary. You can put that break wherever you want it. So, okay. Here we have the things that we are going to actually watch for. Right now, we are actually not going to handle any of them, actually. What we are going to do instead is we're going to use the thing that I told you about in the original intro stream, where I was talking about how we can output stuff to the debug stream that shows up in the debugger. I am just going to go ahead and print out when I get any of these messages. So the only thing that I'm going to do is just print this stuff out. That's it. Nothing else is going to happen in here, right? That's it. Just these things. Okay. You know what? I'm going to print out the default because there's going to be a ton of messages that flood in there. I don't think I'm going to print out the default. Well, oh, it's so tempting. Let's go ahead and put that in there, and then we'll just turn it on in a second. We won't turn it on at first. So if you remember from the intro stream, output debug string is basically just a call that allows you to output something to this window over here, this window right here. It will show up in the debugger, we can watch it, and it's a good way when we are just starting a Windows program and we do not have anything implemented, we cannot really log anything, we can't use any of our own debug services that we may have written to do debugging. It is a good way to kind of bootstrap things because it will be a nice little place to print things out as you go, and you know that that code got executed. So, now, you'll notice that there is an L result. An L result is returned from this, okay? And what an L result is an L result is basically just a return code. It's something that we return back to say what we basically did with the message. So each one of these messages, Windows has certain meanings that it will assign to what we return. And if you look in MSDN, you can actually see what those are. So you go in here, and it'll basically say, if an application processes the message, it should return 0. Right? So basically what that's saying is if we actually handled the message, which in this case I suppose we did, we should return 0. So what I'm going to do instead is I'm just going to set result equal to 0 and assume that we handled the message, because the next thing that we have to do to finish our window procedure is we have to basically do a catch-all to handle all the messages that we don't handle. And in there I am going to assign result, right? I'm going to assign that return value, and I got to obviously return the return value here eventually as well from the function. I'm going to assign to that return value basically the result of calling Windows's default window callback, which they have defined. And what that basically is it's a catch-all that says if you don't want to worry about particular messages, you can call me and I handle all the messages in whatever the default way is. So it's basically like saying, okay, I am sort of the first person on the food chain for these messages. My main window callback will be the one who looks at the messages and goes, is it one of these 4 that I care about? But if it's not one of the 4 that I care about, I can go ahead and pass it on to Windows and let it do the default behavior. And as you'll see, we may actually even want to do that for some of these messages and other messages we might handle in the future. We may still even want to call the default window procedure even when we do handle a message, because we may just want to do something extra than what it does, if that makes sense. So the default window procedure is documented in all of these things, basically, and it's just called def window proc. You can click on it and see its definition, and as you might expect, it looks absolutely identical to, well, that is, if my internet is still working. Let's hope that it is, since we've been having problems today with it. Yeah. I need to get some kind of guaranteed internet so my stream can't be interrupted, if that's possible. Anyway, the default window procedure is literally exactly the same function signature as ours, only instead of it being a callback where Windows calls us, it is a Win API, which means that we are calling it. Now, callback and Win API, I mentioned them a little bit in the intro stream. They are a decoration that specifies a calling convention. We have not gotten to calling conventions yet, so I'm going to kind of defer talking about what those are for a little while, but otherwise, you can see that it's exactly the same. It returns an L result, which is basically just, again, it's just an unsigned integer, I believe, is all, or it might be a signed integer. Let's take a look. We can actually take a look at what L result is actually defined to be in the Windows headers. So inside here, Windows data types, it does look like it's signed there. Come on, MSDN, you can do it. I know you can return it. There we go. So if you come in here, Windows data types, it will actually tell you what they all are. And you can actually see the pound defines that specify the actual literal value of these things. So if we go to an L result, you can see that it's defined to be a long pointer. Okay, that is not what I was expecting it to be, but I guess they want you to be able to return pointer values in there, which means it will actually potentially be 64 bits on our device, I guess. You know what? Since that's interesting to me, let's pause for 1 second and let's take a look. Let's see what's going on here. Size of L result. Oh, you know what? I don't even have to do that here. We can just go ahead and kind of pause what we were doing, right? All of this should still be valid code. Looks like valid code to me. So let's go ahead and build that. Everything builds fine. And I'm just going to go exploring. So we go in here. This is our, well, you know, I don't even think I need to do that. Let's go in here. Let's see if I can take it, the size of it right here, or if it's because it's a pound defined. Yeah, there we go. So size of L result returns 8, which, as you remember, it's all in bytes, so that means 8 bytes, which means 64 bits, which is exactly what we thought when we saw long pointer. So basically what they've done here is they have said, okay, main window callback returns something that is 64 bits, And that way they could return, probably the reason they're doing that is because that way they can return anything, any single value that they want to, including a pointer to something, which because we are compiling in 64-bit mode, you remember VCVARS32, we called, in fact I can show you right here in the MISC, shell.bat. Remember this little guy here, compiling in 64-bit mode? Well, that's what that means. Since our memory 64-bit address space needs 64-bit pointers, something we'll be getting to later because we don't actually need to worry too much about the size of things. But point being, since Windows wants us to be able to return things that are pointer size, it needs full 64 bits there. Even if we don't use the full 64 bits for most messages, it needs to be big enough to handle the return value of the biggest message. So that is good to know. I think the last time I really seriously thought about window procedures, it was still in 32-bit Windows, and those were 32 bits long. So hey, they're 64 bits now. The times, they are a-changin'. So we are going to go ahead and call def window proc. It is just a pass-through, and we are going to pass it the exact parameters that we were given. We have no idea what they mean. We don't care. We figure it will figure it out. So all we will have to do is figure out what the parameters mean for these messages so that we can handle them. All right, so now we'll compile this just to make sure we haven't done anything wrong. Everything compiles fine, no errors. And what we're going to do now is we're actually going to open a window using the window class. But in order to do that, we of course have to do what's called registering the window class. So the way that that works is we use a thing called register window class or register wind class. I don't remember the thing. Let's take a look here. Don't remember the exact spelling of register wind class. Register window class. Register class. Let's see. Register class. That's what we want. So I was wrong in both guesses. Register class. We are going to go ahead and register class. And register class just takes a pointer to our window class, the window class that we are trying to register. Now you notice it returns something called an atom. And you may ask, what is an atom? Well, an atom was just something that was used in the old days. Windows, I mean, they're still around, but you almost never actually use them. They were basically things used in Windows to sort of mementoize, to like remember a particular string value or value you wanted to refer to again. And in fact, I don't know if I can find an actual, let me see if I can find an actual thing to show you here, where you just register an actual atom. Let me take a look. You know what? Because I think if I dig deep into the old thing here, let's take a look. Query cancel autoplay, for example. I think that will show us an example of that. Let's take a look. Let's take a look. Yes. So here was a typical one, for example, that I remember being an atom-based thing, if I am not very much in error. Is it not? No. All right. Darn. All right. I do not know then. I do not know a good example of something where we're still going to use an atom. Racking my brain. I'm sorry I can't think of it. Someone in the chat probably knows, and it really isn't that important, so we're not going to dwell on it for now. But point being, we probably will not see atoms much at all. You used to use them for things like, and like I said, we're not going to use these, but you'd get an atom back if you wanted to register a named property that you could associate with a window and other things like this. But we have no need for any of that stuff, so racking my brain again, but I can't think of anything. I thought cancel autoplay might be one, but I can't think of anything that we're going to do besides this one call that actually uses an atom, and we're not even going to use the atom. We're just going to register the class, and that's all we're probably going to do. So we go ahead and register this window class. Registering the window class technically could fail, and so we could check to see whether when the atom comes back, at least I think that it can fail. Let's take a look. Function succeeds, let's see, function fails, return value is 0. So technically, if we want to, we can just double check to make sure that this succeeds. It never actually in practice fails, but if it does, you know, if we want to start being correct, once we actually build a nice little logging system and an error system, which we will be getting to later on, we may want to log that. Why not, for complete mistake? I don't know how we will ever test it. Probably, I guess we could test it by registering the window class twice, because I think maybe it would fail. Nah, it would probably just return us the same atom again. Well, I don't know. We can try. Anyway, once we register the window class, we can then create something of the window class. We can ask it to create a window for us, and this will be our window handle. We can call create window, and create window is a function that will create a window of some class that you specify. Now we might want to specify extra things to it, so there's actually two versions. There's the old version, which is create window, and there's a new version, which is create window EX, which has a few more parameters. So we're going to use the newer version, which is create window EX, which is just a sort of a newer version of it, and we are going to call that oops, there we go. We are going to call that to create our window. So here we go, create window EX, there we go. And we are going to fill out, much like we did with the structure, even though this one is not structured. You know what, I'm just gonna go ahead and do a rectangular kill there to get rid of all of those guys, there we go. So I'm going to use this to basically create the window, and I'm going to pass it all of the things that it asks for. Now, extended style is another one of those bit fields like we saw up here, where you OR together a bunch of bits that tell you what style you want. I don't think we want any of those styles just yet, but we can double check in here. Here's extended window styles that we can go in here. Again, MSDN being so slow is a real bummer. It is kind of slowing down the stream in an unfortunate way. So I'm actually going to sort of preload a few of those here. Okay, here we go. So the extended files, accept files if we want drag and drop. We don't really want that. Top level window in the taskbar, client edge, composited. I don't really know. Paint all ascendants from bottom up order. Doesn't really seem like there's much here we want. We are not layer window. We don't need left alignment, scroll bars, empty no activate, blah, 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 blah. I don't think we need any of these right now. So we are just going to pass 0 as the extended style. The class name is, of course, the class that we just registered. So we're just going to go ahead and straight up pass it out of the struct that we had filled out before. The window name for now is going to be Handmade Hero until we have some other reason for changing that. And now we get to the actual window style, which we do want to specify. And there's a whole bunch of things you can say, like whether or not the window has a border, whether it has a caption on it, you know, all sorts of things like this. But we probably don't need to worry too much about those, because there is a aggregate style that basically just creates a default window that has the standard stuff that you usually want to have on it. So we are just going to specify that, which is an aggregation of all of these different flags that we might want to use, right? All good. So we're going to do that. And the other thing we're going to specify at the moment, which we may retract later, because we may want to create it invisible first and then do some shenanigans, but we are also going to specify WS visible, because if we say otherwise, it may not start visible. I don't remember if overlapped windows, because of some interaction with the flags, actually will automatically be visible when you create them, but normally when you create a window, it is invisible and waits for you to show it. And we are not going to quite do that yet. So now we can pass X, Y, width, and height for the window. And what we are going to do there is we are actually going to pass this special value called CW's default. Normally you would actually specify the coordinates on the screen that you would want to do. And we don't want to really talk about coordinates just yet, because that is something we're going to talk about later. So we're just going to pass use default, which just says open this window on the screen anywhere that you want to. And I believe we can do that for the width and height as well. Yes, we can. So that will take care of it for us. Parent window is if you want to have windows inside windows, which we do not want to have, so we do not need to do that. We can pass a 0 for that, and it will assume that we are just a top-level window that is on the desktop. We do not have a menu, so we don't need that. We have an instance, so we're going to go ahead and use that instance. And we do not need to pass anything to our window. There is a way that you can basically pass a parameter to the window. If you were to pass something here as this last parameter, it would basically come in during a message called WM create that comes in here. Oops, if I can spell properly. WM create that comes in here, and you would get that value if you wanted to do something special with it. Okay, so this is basically all we need really to start up. And if we check our window handle when it comes back, we can see down here in the return values, if the function sees the return value is a handle to the new window, if the function fails, return value is null. Now, null happens to be equal to 0, so we can actually just do an if on the value, and that will be the same as checking for null. Some people love to actually type the word null all the time, just in case null changes from being defined to be 0 to be something else. I don't love it, so I don't. But if you are the kind of person who really cares about something like that, you would type this. But we're not going to do that. Okay, same deal here. This will almost never fail in any practical circumstance, but if we have a nice error handling system that we will develop in the future, we may want to start handling that. So I'm going to mark that with a to-do, just so we know there's something to do there. Now, once we get in here, we have one last thing to do before we will show our window on the screen, and that is that we need to start a message loop. Windows does not by default start sending messages to your window unless you actually start pulling them off of what's called a queue. And the way this works is...
This is wild. It's like we haven't even opened the window yet. This is crazy. But I mean, yeah. Considering... Well, I was thinking for a second. Should I use like GTK or OpenGL? Then I was like, nah, I just stick to STL. But the question is, STL3 custom render. Okay, I know, but this is. Can I define my own renderer? That is the question, because I do like the idea of just using STL for the window and then just doing everything ourselves. Let me see, create 2D rendering context for the window. Huh, that's what it was for. List of available renderers. Let me ask Cloud. Can I use my own renderer? Let's see. Wait. Okay, I think I'll look it up later. Where did it go? Yeah.
Anytime you have an application in Windows, it creates a queue of messages for you that essentially starts filling up with messages that Windows is trying to send you, or anyone else who's trying to send you a message through the Windows system for that matter. And what we need to do is we need to loop through our messages, and we need to extract them so that we can send them to our window. And the way we're going to do that temporarily is we're going to use that with the getMessage function. Now, what the getMessage function does is that basically allows us to pull messages off of our queue. And if there are no messages in the queue, it will just sit there and wait. Now, it takes a pointer. Again, I don't know if you remember me discussing in the original stream that basically Windows likes to use Hungarian notation. So LP means long pointer. So instead of writing this, which would be much clearer in the function signature, they write this and make you have to know that P means pointer. It's annoying, but that is the way Windows works. So this is just an MSG, which is another struct that we will look at in a second. And that is an MSG pointer. So we are going to take the address of that and pass it to Windows so it knows where to put the message that it retrieves. We are going to pass the window handle. Well, actually, you know what? We're not going to pass the window handle, because if we have any other windows or messages not bound, we may want to get them. So we can actually pass 0 for that, or null, which will retrieve messages from any window that belongs to us. So that's kind of handy. So we'll just grab all of the messages that are coming in. And these two filters here, filter min and max, are if we're only looking for specific kinds of messages, which we're not. We're looking for all the messages that might be bound for our window because we might want to process them. So what we can do there is we can pass essentially dummy values to that to make sure that we get all of them. Let's see how that actually works here. I forget the magic incantation. User value specify first messages, use W if you are both 0. Get message returns all available messages. So basically what we want to do is just pass all zeros to this function essentially, and that will be what we want to do. Now, we want to keep going. We want to be doing this for a very long time. And as you can see, it says, if the function retrieves a message other than wmQuit, the return value is non-zero. And wmQuit is the thing that would basically be someone's posting a message to our application telling it to exit. So what we would like to do is basically keep running until getMessage returns false, right? If it wasn't a wmQuit. Now, this is not exactly how we will use our message loop in the future. So this is a little bit of a stand-in. So don't take anything I'm saying here too seriously, because yes, you can see this here. The possibility of a -1 return value in the case that h1 is an invalid parameter means that such code can lead to fatal application errors. Instead, use code like this, and you can see that they've written it here. This was the thing that I was referring to. Now, we're actually not going to be using getMessage, so we don't have to worry about too much about this. But at the risk of somebody like looking at this and doing the wrong thing, maybe we'll just do it like this, just even to start off on the right foot. But like I said, we won't actually be using this in the future. Oh, it looks like I've got a... Oh, I did it again. I said I would never use Miratory4 on the stream. Sorry, didn't mean to do that. All right, there we go. There's our for statement. So we are going to go ahead and take a look at getMessage here. It's funny that it says bool, but it says it can return a -1. It's kind of fantastic, right? Yeah. What are you going to do, ladies and gentlemen? But basically what we'll do here is we'll say this is the message result that we're going to get. Back it comes. And then we will check on the message result to make sure that it is above 0. If it is above 0, then we will handle it. Otherwise, we will break out of our loop here and exit. So that should be fine. Now, I'm curious to know what they actually define bool to be. They must define it to be a integer type of some kind, because if bool was really only a boolean somehow, which it obviously can't be because that wouldn't probably work in old school C, but if that was a boolean of some kind, then we would not be able to test it for a negative value. So I'm assuming that's an int. I guess we don't need to look it up right now, but point being, I'm assuming bool is actually some kind of an integer that they define there. All right, so we are going to check here. If we get this, then what we have to do is we have to tell Windows to actually translate and dispatch this message. Now, this is total Windows minutia. Basically what it does is translate message is a thing that turns keyboard messages into more proper keyboard messages. We do not have to worry about this at all right now, but we will have to think about it a little bit later, because basically what we have to do is we have to field keyboard messages in the future, and we will want them to be translated properly. Now, for games, it may never actually matter, but I'm going to stick that in there anyway. So ignore this for now. It's a thing that basically takes a message that came in off of the message queue, does some processing on it, and gets it ready to actually send it out. So here we go, back to dispatch message, the function that will actually send messages to Windows that have them. And you can see it's just a thing that, again, actually dispatches the message. Now, these things technically return error codes, but we have no way of actually handling the error codes. If Windows did not want to dispatch one of its messages, there's nothing we can do about it. So there's probably not much point in actually checking these. We could exit the application, but that seems like a little draconian just for failure. So I'm not sure what we would do there. We could log it. Maybe we could log it in the future, but I don't really even know if that's necessary. So this will go ahead and loop forever until we get back something other than a positive result from getMessage. Let's go ahead and compile that. We have some undefined errors, undefined code there in CSU's default. So for some reason that was not there.
Hey Reg, how you doing? Just watching Handmade Hero. Cause decided I want to do it too.
Why? So
Oh, this is really old. It's from 2015. Have you not heard of Handmade Hero? It's quite popular. No, I think it's Windows 7. Or might be. I don't know. Could be. It's really old, so it's possible.
got that straight out of create window, did I not? So I wonder why that was not recognized. Did I spell it wrong or something? Let's find out. So I wanted to pass C. Oh, it's CW. I use.
Yeah, I can. Better open Twitch. Oh no, it's Stream Manager. Just go there. Can I pop this out? Pop out.
Used class style. That's up in here for CS. I was like CS owned to C. This is CW, which is I guess for window. Create window, let's say. I don't know. Who knows how they name things, but they name them. So there we go. And if we go over here and run our program, well, I've got to unset that breakpoint first, but you will notice that we finally have a window on the screen. There is our lovely window. And if we go over here and look at the debug output, you will see that we got our window messages. There they are, activate app, WM size, and that was because as I go ahead and drag around in here, I'm generating tons of WM size messages. If I click on this, we will get the WM close message, as you can see, and we will never get a WM destroy message no matter what we do, because that would have to come basically from something that was going to forcefully try to close the window. Normally we would be calling that ourselves. So there you go, we have a window on the screen. So now what we would like to do, obviously, is we would like to draw something to it, just to prove that we finally have a window that actually has something on it. And the way that we can do that is we can field a message called WM Paint. So inside WM Paint, there we go, we are going to use that DC thing that I was talking about. So basically, what we can do inside WM Paint is we can go ahead and ask Windows to allow us to paint to our window using their graphics API, because on Windows, if we're painting to a window, we have to use it. And so what they have is they have a thing called Begin Paint and End Paint, which allow us to say we are about to update our...
Yeah, it's Casey Muratore. He comes on Primeagen quite often. Yeah, he is. Much younger him, because I think 10 years ago.
Our window, here it is, right? And then we are going to go ahead and use End Paint to tell it when we are done. So here we go to end, oops, it was right there. You can just click on it, End Paint, there it is. So we are going to go into End Paint, there we go. And we're going to pass that window handle that we got here. We're going to pass our window handle. We are going to pass the address of a paint struct, right? Let's see, paint, that it can fill out for us, and it is going to return one of those contexts for us, one of those device contexts. So let's take a look at the documentation of that so we understand what's going on. Inside Begin Paint, we pass it the window that we are trying to paint, right here, right? The handle to the window to be repainted. And we pass it a pointer to one of these paint structs, which is another one of these structs that Windows uses to pass information back and forth. It's passing it out to us this time. So what it's going to do is it's going to fill this out with a bunch of information that we need, such as a rectangle structure, which tells us where we need to paint, a thing which says whether or not it should be erased, this sorts of stuff, whether it's an incremental update, those sorts of things. We're not allowed to test those. Those are internal to the system, as you can see here, labeled that way. But we are going to go ahead and field that in a relatively straightforward way. So we're going to do that, and then End Paint, of course, just takes the window and the paint struct back so that it knows which, just basically to close off the paint. There we go. So all we are going to do is we are going to do a patblit. A patblit is a function which basically just tells Windows, it's sort of a graphics utility, which basically tells it to do blackness or whiteness or do some kind of another bit operation to things. So we just want to fill our window with white for now. That's going to be a very simple thing for us to do just so we can see that we are painting to our window the way that we want to. Okay, device context passes the device context that we're painting with. It takes the the size of the window, right, which we already actually, well, we do know what it is. I'll show you what it is in a second. And then eventually it takes a flag that says, sorry, a value, these are constants, right, whiteness, blackness, DST invert, these are constants defined in the windows.h and assorted header files that tell Patblit what kind of fill it should do to the rectangle that we are going to specify. Now, what is the rectangle? Well, fortunately for us, we actually know what the rectangle is because we got it back from Begin Paint. Remember when I said inside Begin Paint, there was this paint struct here, and this paint struct basically tells us what we need to know. The RC paint, if you go down and look at the documentation for that, is a rect structure that specifies the upper left and lower right corners of the rectangle in which the painting is requested, right? So we basically have in here, after we do that, we have a rectangle. We can go paint, RC paint, like that, and we can access its members. Now, what are the members of a rect? they are what you might expect. The left, the top, the right, and the bottom positions of that rectangle, right? So min and max on x and y. Again, don't worry too much about coordinate systems. We'll be covering them in the next stream, or approximately even the stream after that. And they are longs, which are just yet again another definition for int. Windows has a ton of definitions for integers, depending on what size they are or what exactly they correspond to. But these are basically just integer values, as we will see when we step into this code. So when we do patblit, let's go back to patblit. When we did patblit, oops, that's the one we actually want. There it is. It needs a left, it needs basically the left, the top, and it needs the width and the height. But we didn't have the width and the height. In our rect structure, we have the right and the bottom, which are maxes. So we have to subtract right from left and bottom from top to get that width. We want to see how big those are. So we're going to have to do that, right? We're going to have to do bottom, like this, minus top, right? And we're going to have to do right minus left in order to get those widths and heights that we wanted, right? Oops, backwards. Height is going to be that one, and width, right? And then we already know what our x and y are, right? Because we already know that our x is this. And you know what? Should probably pass the ones that patblit wants. Those are longs in there, but they're defined as ints here, so we might as well convert them out to ints. Like I said, Windows has so many definitions for ints. It's kind of a rat's nest, and most of it's historical at this point. But what are you going to do? We have the x and y for the rectangle that we want to paint. We have the width and the height, so we can go ahead and do it. Width, height. There we go. Nice and clean. See how we compile. Patblit. Well, we know how to deal with this, right? I taught you in the last stream. If an import symbol is not defined, we go down to the bottom here. We take a look at who it was, and we grab that library. gdi32.lib is what we need for patblit. So we are going to go into our build.bat and stick it on the end. There we go. Compile and done. Now when we run, we should see a white window, ladies and gentlemen. Pretty nice, huh? It's lovely. Totally lovely. Absolutely fabulous. That is the best white window that I bet you I've ever seen. Now just to prove how awesome we are, because you know that we are, why don't we do something absolutely ridiculous here? Why don't we just do, sometimes we'll paint it with black, and sometimes we'll paint it with white. Because there was blackness, and there was whiteness, right? So what I could do is I could look at patblit here, go up here, and this is just a little amusing diversion. That's a D word that it wants as the last thing. So what we're going to do here is we're going to take our D word, which is our operation. We are going to assign it to whiteness, right? But I'm going to use the static keyword. Now what the static keyword is normally every variable is local to us, right? Every variable is local to where we defined it. Remember I said these blocks, these braces, the variables are local to us. But what I'm going to do is I'm actually going to say, you know what? I want this variable to persist. I want you to create it, and then I want it to stick around. So that when I come back through here, it will actually be set to whatever the value was the last time we ran this thing. So it's basically creating permanent storage, essentially a global variable. It's almost like we were to declare it out here as a global variable, but unlike a global variable, it is locally scoped to this area in terms of lexical. Like it's lexically scoped, meaning that we can't refer to it anywhere else. So it keeps it kind of contained, but it is global. Now, I never, ever, ever, ever use these. They're a very, 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 very bad idea in code that I actually need to ship. But I always use them when I am debugging, because it's very handy to be able to stick something in really quickly that is there. And this is exactly what I'm doing right now. I just want to debug something to make sure that we are actually painting our window every time. So I'm going to use one now. But I never use these basically because they create nightmares for thread safety and all sorts of other stuff. So we will see a little bit more of that later, but don't do this willy-nilly. This is something I'm only doing right now for debugging purposes. So basically what will happen is the first time we come through here, when you see this static, what it will do is it will initialize operation to whiteness, but the rest of the times through it will not initialize it. Only the first time through will it initialize it to whiteness. The rest of the times it will just leave it at whatever value it was. So what that means is we can, every time we go through here, after we do this clear like this, we can go and say if the operation was whiteness, right? Remember the if statements from our intro stream. We can then set it to blackness. And if it was not equal to whiteness, we will set it back to whiteness, which will basically create a toggle. So when it comes through here and it's set to whiteness, it'll turn to black. When it's set to black, it'll turn to white, and it'll toggle back and forth and back and forth and back and forth. right? Good. We hit run, we get our white window, which is what we expect. We then drag it, and there we go. Don't know if the stream can keep up with that, but we are basically creating a epilepsy window that just to demonstrate when we are redrawing the window. Pretty good for one night's work at only an hour. So hopefully that is enough to tide you over till tomorrow, when we will field these messages a little more appropriately, and we will actually create a bitmap that we can blit to our window, which will take it up to the point where we can actually start to use it to render our game, which is what we need. So I hope that was a good enough, quick introduction of how to get a window onto the screen. Within the space of an hour, there's only so much we can do. But we will be going through tomorrow and flushing this out in more detail and getting a nice proper window that we can actually use for rendering our game in good shape. So thank you so much, everyone, for joining me. I will pause the stream now.
Hey, I mean, there's a few things to do. Hang on, let me do to do. First thing, I think I do have the window, but let's make it resizable. Sizeable window. Draw to window. Window messages. Because I think you can in STL get the messages. The only question is how. Okay, so I want to check focus too loud now, or better. Okay. I've decided to stick with STL. Yeah. Now the question is, what do I gotta do again? Ah, yes. I did do some of this yesterday. See what else can we do with the window. This is what I've used. What if I just create window? But I need the renderer to be able to clear it. Okay, What are the window flags? There's visible, borderless. Ah, I see. Window should not be added to the taskbar. I think this is the only thing I need. Raven, whoa. Window flags. SDL dot. Why is it so big? Hang on. Take build run. I mean, it is resizable. Maybe I should turn off tiling. Can't move it though. I mean, I can barely see it. I don't even see it there. Maybe I should add a background. And that back. This one. Okay, I mean that's better. How come I can't move it? Okay. There. Drag. No. Can't move it at all. I was able to move it yesterday. I don't remember how. Oh yeah. Gotta grab like. Oh, cause the taskbar's missing. I'm not really sure why. That's a problem for later, really. Okay, go to resizable window. Sort of moves around. Create, render. I think this is not needed right now. Okay, I mean, draw color float returns bow. Yep, we'll print a debug message. Draw color. Then done equals true. Maybe I can print the event. I don't know what that means. Oops. They all look the same. I mean, it would be nice. There was a close button. STL poll event. All for currently pending events. What's this bar called? Task bar? Damn, I can do networking too. That's pretty cool. No. Okay. No. What else I gotta do? And, there. Okay. Turn 0 on success. Render response. Okay, it returns a boolean. In which case I can make this the same. Yeah, if and same here. So clear. I think that's good enough. Look at this. This should still work. Don't know what these events are. Oh, but it's like every time I press a key, it's gone now. Okay, I mean, the only question is, do I wanna... If I don't use SDL, I have to use GTK. Not that GTK. X window. How difficult is it to use GTK? Mhm. Maybe STL and GTK. No, not what I wanted to know. I mean, I'm quite tempted to try GTK. Choice GTK 4. Seems quite active. Can use JavaScript. It's wild. I'm also thinking, should I just use C? Maybe not. Do want to use Zig. Okay, I think let's give it a try. Releases. What's this extension? Or I could just get... do I fetch? Take, fetch, save. Did use it before. Not sure which one I used. I think it was this one. Build.zeg. Remove STL. It's a good to get rid of all of this. Interesting. Does it have an example? Yes, it does. imports. Weird. What version of Ziggy using? Must be quite new. Yeah. And just add imports. Module is goobject.module. I don't see. Okay, goobject is here. I guess. Yep. Get rid of this. G-object. No dependency named G-object. What? Say build. Didn't work. Yeah, I can remove that. Able to find module glib 2. Do I even need it? Don't know what that is, don't need that. We'll look at the import. Yeah, the rest don't seem to be used. I should just learn how to link a C library. Okay, let me see if the hello world works. Unable to find module G object. I wonder if it's because I just need to install Oh, yeah, obviously it's not a command. I gotta look this up. I'll do it later. It's a lot of work. I mean, Yeah, so either I stick with STL or use GTK. I do like the idea. I prefer GTK because it seems, well, I don't know yet, but yeah. Question is, what am I missing? Find the latest release of the project. I desired binding artifact as a dependency. I'm not sure what to do with this. Alright, I'll look that up later. I think for now, I'm gonna call it a day there. I mean, the first week's gonna suck because I have no idea what I'm doing. We'll figure it out. Alright, thank you for hanging out as always, and I shall see you tomorrow. See ya.